Hey, welcome everybody here. So, hello everybody. Welcome to SkyTour live stream tonight. This is going to be a good quick stream. We're going to show the supernova again and maybe a couple other things. And of course, with us tonight, as always, Daryl Mason. Hello, Daryl. How are you?
Hello, Mark. I'm good. You?
All right, thanks. So, what's going on at your end of the woods there, Daryl?
Very stormy earlier. We may have another round before the night's over.
Ah, okay.
If we do,
Yeah, we're
you'll
not.
probably hear it.
Oh, that's okay. As long as it doesn't knock out your power, right?
Yeah.
Yeah.
Or hail.
Hello, Tim F. Tim F was the first one in tonight. Hi, Tim. Good to see you. Judy M is next. Renee Cruz. Hi, Renee. Rascally Rabbit is with us. And certainly more coming in. I am going to start off by just checking out our stuff here. I want to make sure that we are in good shape. I think we are. We are currently not looking at. We're looking at the wall in part of the building. We're not actually looking at anything yet. So that's going to change here in a second. So we'll bring ourselves up in the sky a little bit. You can see by our dome cam right there, or our building cam, and then of course we got this one right here. The telescope's looking off to the south, which is toward my head in that view. And we're only at 150 gain right now, so we're kind of low. But we'll go up. I think we might have a young moon tonight. I think we do, actually. And what I'll have to do now is I need to start up our planetarium program as well, which I haven't yet done.
It's 4-day-old moon tonight.
Yeah, that's good. So it's not quite first quarter. It's on its way. It'll be first quarter soon. And we see the moon out there right now. I'm not sure if we can actually see the moon. It's a waxing crescent, but we can probably get it. Let's check out the moon and head there and just do a quick run to the moon. When in doubt, run to the moon. And we're at we're going pretty we're at a 1 second right now at 250 gain. I'm going to go down to 0 gain. There's the moon, and you can see because we are going with such high gain, the moon is very, very bright and overexposed. And what we have is we have this star field that you can see with the moon. Pretty cool. All right, and we're going to just drop ourselves down a little bit. Okay, that's a little too much. I think I did too much. I forgot to set our our speed. Okay. Yeehaw. All right. So let's do that now. All right. And now let's do this. Then we'll come up nice and slowly. Then we'll change and we'll check out the moon at a more reasonable exposure, which we aren't doing right now. It's kind of, bright, a little overexposed. I'm going to welcome our friends on Rumble and Trovo and Twitch and Facebook. I hope you guys are having a good time and hanging out with us, enjoying. And I am going to take now the exposure and bring us down to a more reasonable setup. Okay, I'm going to do that now. Here we go. So let's drop it down. Here we are, and the gain is at 0, so we're actually pretty bright, even with the gain being 0. And let me try that for this. All right, and gonna take our exposure down a little bit more. Yeah. Interesting. So there's our green moon in our kind of our night vision mode. But now you can see, see we're at auto. So this means this field you see right here, this is the full extent of our field, the full extent. And so what we've done is, you see you can go 4 full moons across and 3 full moons tall, and that is the extent of our field, 2 degrees by 1.5 degrees. Right, so that's pretty neat. And if we drop our exposure a little more, okay, and do a correction here. Let's actually go down like this, and then let's bring it up so we can see the moon. Interesting how that's working. It's because we have the gain so low, but the moon wasn't bright enough yet to make a real stink. But we'll go to about 100 and then recorrect. All right. Let's go to 75 milliseconds. And go down to 35. We'll be heading to Measure 101 shortly to check it out. And I'll be in just a little bit. Alright. Well, I figure while the moon's here, we'll check it out. Now, if there was ever any doubt, by the way, just to show you, and this is something that I shouldn't even have to say, but there are people that need it said to. None of our audience. You guys are very smart. But here you see the whole moon, and you see this curve. That's what happens when a ball is lit by a sun. Some people just don't believe that the moon was a ball. Okay, they think the Earth is flat. They think the moon is a projection. Oh my gosh. And again, none of you are like that. But I'll tell you, it's really maddening how many people actually think that I've run across. Crazy. Anyway, let's see. I want to say hi. We've got Bonnie is with us on Ohata 77. Cyclone is with us. Okay, I see Gladys is with us. Hi, Gladys. Good to see you again. And who else has joined us? Daisy and the Cowboy. How are you guys? It's good to see you. Prow's with us. Nice to see you, Prow. And let's see, Papa Tom has joined us. Nice, very good. Imboxter is with us. Hey, Imboxter, how are you? Or I'm Boxter. Very cool. Papa Tom has a question for you, Daryl.
I saw that. I answered him.
All right.
It's Venus,
here.
Papa Tom. I'm sorry?
I was just saying, I thought you already answered him.
I did.
Sorry. Okay.
Yeah,
so
Venus, brightest thing in the sky after the sun and the moon, and Venus is coming closer to Earth. It's going to be highest in the sky, greatest separation from the sun on June the 4th. It will continue getting brighter. After that's it, rounding the corner. It'll be about half full. and the size of the crescent will continue growing, but the crescent will get skinnier night by night as it's coming around to pass between Earth and the Sun.
I assume his question was, what's the bright object near the moon?
What's a bright object, star-like object after sunset?
Oh, okay, cool. Very nice. Gladys, why'd you say bye? What's going on? Does he have to go? Oh, she says she has to go. I'm sorry. All right, well, you know what? We'll try to be here when you get back, Gladys. Good to see you, even if it's for just a short time. Thank you for stopping by. All right, let's, there's our moon, like I said, looks nice. Geez, we'll take a snapshot of it. And it's been saved out there. All right. So we took a snapshot. Okay, you can see where the telescope is pointing. It's pointing a little over to the west. And if we look at the cam that I'm blocking, it looks like this. So we're looking at the telescope pointing toward the west. And we're down low looking up at the telescope looking out of the building. All right. I gotta say, I still, it boggles my mind that this is happening 2,500 miles away. I don't get it. I mean, yes, I appreciate technology, but boy, this is crazy. All right, let's go to our planetarium program here, and let's now go do what we came for. Let's check out Measure 101. Might be a little early for it in terms of the darkness of the sky. Well, let's check it out. Maybe it's good. At least we'll be able to see the supernova. You can see the telescope is moving right here. Yeah, there it is. Heading toward the location in the sky. You can see it zipping by up there. Okay. All right. And now in here, we should see it. And for this, I'm going to increase our time, the exposure to 1 second. All right. And now we see stars. And then we hit that adjustment. We're going to go to 200 gain at the moment and adjust again. And I think the galaxy is right here, and you can see the supernova right there.
Yep.
Right there. It's really bright. Okay, so what we're going to do is we're going to move the telescope westward. As you can see, the sky is still a little bright. That's okay. That'd be okay with me. All right, we're going to move over. And we're going to move south a little bit. There we go. Perfect. All right. Hey, Ronald's here. ERRT Radio on Mixlr. Check him out. He's got some great shows up on Mixlr. Yep. I want to take a moment to thank our patrons. We have a few. And the ones that I think help make all the difference are these guys right here. All right, we have John P., Izabela M., Ali B., Chief McCyber, Vera C., Ronald T., ERT, okay, and Martin W., Raymond B., Cindy M., Terry H., Susan W., and Diane H. Thank you for our amazing patrons who have joined us to help support us each month. If you can think of it, or you just want to make a one-time donation, you can visit us at skytourlive.org. Check us out and head to the Patreon if you like. I think in the Patreon you can make a one-time donation. You don't have to make it a recurring thing if you don't want to. But the recurring donations get you stuff. And we are in the process, I started it today, of hooking up all of our products. I'm waiting for it to get fully dark, by the way, which is why, we're not just starting an exposure here yet. You can find all of our products. You'll be able to find them on several stores online. If all goes well, we'll be selling on Walmart. We'll be selling on Shopify and Etsy in the short term. And yeah, Walmart. We'll be a Walmart partner, but that's that's an online thing, and who knows? No one might even find our really cool sneakers that have our stuff on them. We have the neatest sneakers. They're just so cool because I wear them when I do my talks. They have SkyTour live stream on the side, and the whole sneaker is covered with one of our nebulae. You can get anything you want on them too. It's kind of cool. All right. This is still a little bright. We'll try 12 seconds and see if that's going to give us a blown out image or not. So let's go into the live stack here. I purposely waited longer tonight to start the stream. And make sure you're at 1080p. Okay. Oh, wow, we can see it very nicely. All right, let's bring in some detail. Okay, and let's color correct. That's pretty good. I haven't focused yet, so we're going to do that as well. And we can do that in this field. That's not a problem. Okay. But you can see right there, boy, that the supernova is quite bright. Look at that. And we have to refocus, I can tell. But it's still bright. And it's going to be like this potentially for weeks to come. So that's really interesting.
Uh-huh. I've been watching. Right. I haven't seen the magnitude change yet. Surely it is.
Yeah, I'm thinking it certainly is. I'm going to come back to our night vision mode for a focus run, and then we'll come back in and take pictures again. I just want to make sure that we do that. So yeah, we have lots of stars, but I want to defocus it so it can run itself into focus and then back out of focus and know where focus is. All right, so we're going to scan in now because we went out of focus. We racked out. Now we're going to rack in and go to our focus point. And we're building a parabola over here. You're going to see a curve that's generated. That curve is going to be down here. And where it's at the bottom of the curve is going to be the perfect focus location. So it's coming down from out of focus into focus. It'll end up down at the bottom, and then it's going to start going out again. You'll see that curve go back up. All right.
Izabela's here.
Izabela. We know Izabela. Sam S. is here, too. Hi, Sam. Good evening, Izabela, from Sofia, Bulgaria. There's our curve. See our curve? It's like a slip and slide. Whoa! But that's where you want to stop. Okay. So we are actually, that's a good point. I don't actually have to wait. I can just tell it to go to best focus now. So it's going to rack all the way back to the other side where it began, and then rack back in to a point of perfect focus. So that looks good. Okay. All right. So now that we are focused, let's bring in a full field. there is our galaxy right here. Let's actually try to do a 12-second shot again. Let's actually go 15 seconds now. Got a little darker in the interim. Okay, 15 seconds. I was on a show today that was where we talked all about the SkyTour live stream for much of the show. And a pretty popular show. And then I'm doing another one tomorrow. And they say they have 4.5 million listeners. So I'm hopeful that we'll get a lot of people that want to see this. You know? And I know I keep saying this, but you know what? No one's doing this. I don't know. I don't get it. You know? This is something that, you know, I can't say it's easy to do. It's certainly not. But I would think that more people would be interested in sharing the night sky like this. Now, there's plenty of people streaming astronomy, and they take pictures of like an object, and they spend the whole night on it. But they don't talk about the object. There's no discussions. There's no, person sitting there helping along like Daryl does for us, for all of you. So we are literally, in this way, we're the only game in town. I don't understand why there's not more people doing this. I just don't.
I hate to break it to you, somebody else is doing astronomy live streams.
Well, there's plenty of people doing live streams, but there's nobody that's taking pictures like we do of like 10, 12 objects a night and provide them free to everybody on a server. There's nobody doing that. If there is, I don't know about it.
Yeah. If I see them again, I'll let you know.
Okay. I know that some observatories will do a live stream once in a while, but I don't ever see anybody, doing more than taking a picture of one object a night, or maybe two objects. We do have a rather unique instrument, so that's pretty cool. There's a lot of instruments that have the same setup as ours, but apparently not a lot of them that are broadcasting to the world. Philos 4R, how are you? Philos is with us. Good to see you. Red Storm here. How you doing, man? Yeah. And so for those that haven't seen it before, this is Measure 101. It is a galaxy, of course. And what I'll show you is where this supernova is. It's right here. It's inside this red box. It's right in the center of that red box. That blue object right there in the middle. Okay. Now, what you can do as a matter of, as a rule actually, is you compare that supernova brightness to the brightness of the nucleus of the galaxy right here. All right. Oops, not quite there. Sorry. So what that shows you, all right, is that object that we're looking at, all right, if you compare the brightness of the center of the galaxy here, okay, with the supernova right here, and then you say, wow, this is brighter than the nucleus of the galaxy. And the brightest part of a galaxy is the nucleus in most cases. So if this is brighter than the nucleus of the galaxy, it means that it's outshining the whole nucleus of this galaxy. That's pretty impressive, because the center of this galaxy has thousands, if not millions, of stars in it. And their light together is not brighter than this one star that has exploded. That's the interesting thing here. And I think Daryl had information yesterday that he had looked up that this supernova actually was at a brightness that is consistent with being one of the brightest stellar supernovae that we've seen in a while. I think you said magnitude 10?
10.8. I checked them again earlier tonight, and they haven't moved off that number. I'm not sure they've updated the page the last few days.
Okay. Was this Sky Live?
No. That's a good point. That's somebody I should check. This was University of Rochester Astronomy, something or other.
Okay.
In fact, why don't I check Sky Live right now?
All right. Let's do some processing. There we go. You'll notice when you look at the galaxy like this, guys, you'll see that the galaxy has very blue arms, and the center's orange or yellowy orange. Why? Well, it turns out that the galaxy makes all of its new stars in the arms of the galaxy. All right, that's where they are made. These areas here, you can see there's knots of bluish stuff in here, knots of blue over here. These are hot young stars, associations of hot young stars, and these are really, really well, for all it matters, these young hot stars are the pulse of the galaxy. You know, these stars are forming in these areas where the spiral arms are dense, and then they tend to be hot, young, and very massive. And the more massive the star is, the more dangerous it is for the longevity of the star, because the star will in fact go supernova, and supernova is when a very massive star burns through its fuel so quickly that it can't output any radiation to hold itself up anymore, and its own gravity collapses it. And imagine if you had what would be approximately 4 trillion tons of material falling down on your head from all sides. And what's going to happen? Nothing good. Nothing good would happen. And so it would just go boom. It would hit in the center and rebound outward. And the thing that's interesting is, I've mentioned this before a supernova occurs visually, before you see it, it might already be underway inside the star. Stars are so big that it takes a while for physical particles to make their way out of the star. Sometimes many, many hours. So one thing that does get out of the star relatively unscathed is a particle called a neutrino. And 1 in a billion, with a B, 1 in a billion get out of a star during this process of supernova. And when it happens, this process will basically unleash untold, as far as we're concerned, effectively an infinite number of neutrinos, because there's an unbelievable number that are being stopped, but even more get out, right? So over time, in fact, a short amount of time, these neutrinos get out of the star and make their way to wherever they go in all directions. And if we're listening for them, which we are, we'll see the neutrino trails, and we'll see the neutrino evidence, and we'll know at that point, hey, there's a supernova coming. And where is it? Well, I suspect the supernova coming is going to be in the direction that the neutrinos are coming from, right? Let's be clear. So when you look in that direction, you may not see anything yet. And that's because the shock wave from the supernova is still expanding inside the star. And when it breaches the surface, that's when the star is going to be fully involved in the supernova, and that's when it would be visible. Now, why would it take hours for material to get to the surface? Are stars that big? Our sun is 1 million miles across. All right? For a star like our sun, it will never go supernova. It's too small. In other words, it's not massive enough. But for a star the size of, say, Betelgeuse or Antares, okay, or VY Canis Majoris, one of the biggest stars in the universe, these stars are so big that if you put them where the sun is, then their orbits would be out as far, their diameters would take them out as far as Jupiter, or Mars, or even Jupiter, or beyond. So you can see it would take many, many hours for material that's exploding in the core to make its way out to the surface of the star and breach the surface. But the neutrinos, at the speed of light, get out relatively unscathed, and the material, the physical material that's moving, can't go the speed of light, so it's slower, so it lags behind. The neutrinos burst out. We see the neutrinos. Hey, supernova coming. Turn your telescopes toward the source of the neutrinos if you can, pinpoint it, and boom, you're greeted with a supernova. Isn't that amazing? It's all about timing. I just thought I would offer that to anyone that was interested.
There are billions of neutrinos passing through you every second.
That's right, from all parts of the universe. That's correct. Good thing they don't cause health problems, huh?
Yeah.
There'd be no life in the universe. Okay, we're going to stop at 40 frames here. And then I'll save it. So, alright, M101 with supernova. Okay. And we'll save it. And when I say save it, what's happening, okay, for those that are newcomers, that green bar says that we saved it as a .fits file, a FITS file. What's that and how could you use it? Most people won't, but the FITS file is the raw data, so if you want to process this on yourself using Photoshop, you can. Now, the next thing is when we do a save, we save it exactly as seen. So then this image that you see right here is saved as a PNG file. And if we click it, you'll see just how it's saved on our server. That's what's on our server right now. Okay? And so if we zoom in, okay, you can actually see lots of detail. You see that? We've got lots of bandwidth, a lot of high dynamic range with this camera, so we can zoom in fairly substantially. There's the supernova right there, and it's right next to this other orangey area, which is a large stellar nursery complex or a nebula complex, kind of like thousands of Orion nebulas in that region. Okay, so that's what you get. Now, what I'll do is to make one that's a little bit more interesting visually, I will just do this. I'll darken it up a little bit. And by the way, I'm very excited that the summer sky is coming up.
Say what?
I'm very excited that the summer sky is coming up.
Oh, sure.
Yeah.
We'll be able to show cosmic ray, the Red Nebula, every night.
Every night, over and over. I can't wait to show them.
Yeah.
Hello, Terry Haig. Terry Haig is with us. Hello. There's cosmic ray. And he says the spectra for that supernova is out. That's fantastic. And I'm sure it shows it was a core collapse supernova. That's what everybody's been thinking. Red Storm, I am in Connecticut, but the telescope is 2,500 miles away from me. That telescope's actually out in Arizona, in the middle of the Sonoran Desert. And I'm controlling it remotely from Connecticut, and that's how we deliver and bring you SkyTour live stream. I'm actually wearing a little jacket right now because in Connecticut right now it's in the 50s, maybe in the upper 40s, and the temperature out in the building, is in Celsius now. It's 26 Celsius in the building. You can convert that to Fahrenheit, and you'll see that it's a darn sight higher than the 46 and 50s Fahrenheit we have here. Okay. Let's save it one more time. All right. Now we're going to clear it. I'll tell you why. This is only a 15-second exposure. What we're going to do now is we're going to take a 60-second exposure. Why would you do that, Mark? Because I want to. So we're going to start a 60-second exposure stack just to see if we can get some additional detail in the galaxy that we're missing. And I'm actually also only at 200 gain, so going up higher at a 60-second exposure is a good idea. So indeed.
Whoop, you didn't turn your T-comp on when you did your focus.
That's correct. You're right. I guess I'll do that. I turned it on and the focus didn't change, so we didn't lose anything. Alright, so there's our 60-second exposure. Let's actually balance all the levels. Okay, and this is just the first one. Do a color balance. Alright, and let's bring this in a little bit. This is our dark level. We have some noise, and we only have one image stacked. When you see the second image stacked, all of a sudden you're going to find, and when I say stack, I mean we take an image and then we take a second one, align it with the first, stack it, perfectly register, and do that, make an image sandwich. That image sandwich brings out all the subtle details, because that's real data that never changes frame to frame. Now watch this. Ready? Watch the difference. Here it comes. Oh, great. Well, you can see the galaxy better, and we had a satellite go right through the middle of the shot. Look at that.
Thanks, Elon.
Now, I don't know if that's probably a Starlink, huh? But it's a little yellow.
It's true.
It could be the International Space Station for all we know. But here's what I'm going to do. I'm actually going to save that exactly as seen, because that's sort of an interesting keeper of a shot. Bisecting a galaxy. Almost. Alright. And we'll save the raw file, even though it's only just a few frames. That kind of ruins the shot a little bit. Alright, we'll clear it. I already saved it, so it'll be out there. And what I'll do is, in the meantime, I will change this to 45 seconds, the exposure, and I will have the gain set to 250. And now we'll clear that and start over again. All right. So how is everybody doing tonight? I hope you guys are doing well. I've been having a good time here. I'm preparing to leave. Tomorrow I do a show called Night Dreams. And then next Wednesday, a week from today, I fly to California. Actually, I'm flying to Phoenix first, where I will then meet up with the people that will be going with us, Kriston T. Harris, Marianne, and myself, and a few others are driving to the conference location in California. And I will be doing this, a live stream there, among other things. I'll also be doing a talk on some concepts within string theory that, for laymen, for people who don't have an understanding of physics, to show them how it's possible for interstellar craft to go vast distances without actually having to go vast distances through space. It's really interesting. And some other physicist and aeronautical engineer friend of mine the aeronautical engineer named Bob Schroeder, Bob Schroeder, yeah. Bob came up with this concept, and I have to say that as soon as he mentioned it, as soon as I read up on it, as soon as I looked at what he was talking about, I felt he was right on the money. If there's extraterrestrial life and they do get advanced, they can be here. They really can. And that's something that was really like a slap in the back of the head. It's like, of course they can. Wow. And the thing that's interesting about that is that they could be here and they wouldn't be using generation ships to get here. They would actually be able to get here in a reasonable amount of time. For instance, there is one calculation that was done by a physicist that said they could go to Alpha Centauri in the using a small amount of this technology in 20 minutes. And to hear a physicist say that with a straight face, again, an accomplished physicist, is pretty interesting. So that was something that we have to consider as a strong plus, because CERN and the folks that have the particle accelerator over there are investigating the very same particles that the physicists and the aeronautical engineers said were the ones that they would use. They have a name. They're called Kaluza-Klein particles. K-A-L-U-Z-A, Klein, K-L-E-I-N. And if you look up Kaluza-Klein particles and CERN, C-E-R-N, you'll be amazed at the article that's up there about it. So check it out. Hey, Lambda Theta Psi, how you doing? I don't think that they're not here. I think they are here. They've had plenty of time to get here, and you know why? Because we have a particular item that all carbon-based life, which I think is predominantly what the universe is going to be composed of, carbon-based life. Carbon's the fourth most abundant element, oxygen the third most abundant, even more so than carbon. And so they would have been here because they would have noticed from literally well over 1.5 billion light years away, literally, they would have noticed that there is oxygen in the atmosphere of this planet. And that's something that is very important, because carbon-based creatures will require oxygen to make energy, food, and carry on their existence. So it's pretty interesting, So I think that based on the fact that oxygen began building up in our atmosphere 2.5 billion years ago, whereas my favorite astronomer Carl Sagan would say, oxygen built up 2.5 billion years ago. And when it built up like that, that became a beacon to all life elsewhere. Stephen Hawking said, no, don't raise our heads up. Let's stay hidden below the galactic radar. We don't want anyone to know. And I think that it's very important to understand that oxygen gave us away long ago, long before we had any inkling of our own existence. Jeremy B. says, not a fan of CERN. I don't know what your experience has been with them, but my experience has been that they are actually way more cautious than people think. They can't blow up the Earth. They can't make runaway reactions that will consume all matter. That's just not true. Saren Man says, excuse my ignorance, but why do stars lack color? They don't actually, Saren Man. That's just that when we take photos of them, the photos sort of saturate the core of the star, right? But there's many stars that have lots of different colors. And the colors are going to be going from blue to white to yellow to orange, and to red. Okay, and you'll notice there's no green in there. There are no green stars ever, promise. And the reason has to do with what's called black body radiation and how that works. When we see something hot that cools down, it goes from blue hot, which is the hottest, to blue, okay, to white hot, to yellow hot, to orange hot, and then just red hot with a dull glow. Okay, and that is a consequence of the way things cool. It's a physics. It's just the observation of nature. And stars are hot plasma balls of gas. And so they follow that same rule. You have a hot blue star and you have a very cool red star. But you don't have a green star. Hello, Preston. Welcome. Nice to see you.
Whoops. Would you excuse me a moment, please?
Yeah. Preston asks, if you embody an intelligence that would, what would you call that? If you embody an intelligence, what would you call that? Please define embody for me. Jeremy B says, we don't know enough to be fooling around with that half of the stuff that we do. Clueless about so much of everything. Earth, the universe, just everything. We think we are a dominant species. Well, on Earth, we are a dominant species as far as we know. But you're absolutely right. You know, we don't know everything. And, you know, there are times in history when we did not make measured, careful steps. You're absolutely right. But the fact is, there are also times that we have. And a lot of the stuff that the folks at CERN do is very, very carefully measured out. Now, you might think they've got that gigantic accelerator and they're sending all these massive particles around in these loops. They could cause serious damage if it ever got loose. Well, the fact is, they're not sending around any particles of any substantial amount. They're actually working with little things that are just tiny little particle clumps, and they're sending them in a like a 16-mile run, and keeping them in a curve with a magnetic field, and then colliding them in a tank, and they watch which way they go, and the way they split apart tells them what they're made of, because certain particles go a certain way. Some spin this way, some go this way, some go straight, some curve slowly, and those are characteristic of certain particles. So it's pretty interesting how that works. But it's not something that is harmful to us. They're not doing anything harmful. They never have. Now, playing with nuclear reactors can be harmful. Okay? And as Daisians always say, they say, we will burn our fingers if we keep playing with fire. That's true. So we have to be careful what we do with fire. And you say, well, what's the likelihood that we'll be careful the entire time? It's not very high, and sometimes, you know, history shows that we've made some mistakes. But what CERN is doing isn't anything that can blow up the world. Most of what they do, I mean, that accelerator's not firing 24 hours a day and doing stuff. But if you want to be concerned about something, you might want to be concerned about Lawrence Livermore Laboratory. I'm not, but some people will be, because they announced that they were able to create a sustained fusion reaction some months ago. And on the face of it, it looks pretty cool, but it didn't actually happen exactly that way. But still, it's really interesting. Hello, Dr. Fox 2000. How are you? Dr. Fox 2000, by the way, folks. Go check out his channel. All right? Look him up on YouTube. He is an endless font of amazement when he talks about volcanoes, seismology. Really, really good. Really good. I really enjoy his talks on volcanoes and things. And that's coming from someone who knows a lot about volcanoes. And I enjoy the way he delivers the message. It's really cool. So check him out. do join him on his channel if you get a chance. He's really good. And it's good to see you here, Dr. Fox. So, here we go. We've done, this is a 45-second shot. And we're catching quite a bit of detail here. And we are at 250 gain. And when I say I'm at 250 gain, okay, what I'm really telling you is that I'm looking at these two settings. I'm looking at this one here, which is the exposure, and I'm looking at this one here, which is the gain. And these are really the two things that you should look at so you know where we are. 45 second of letting light fall on the sensor, and we're making it sensitive enough to, at 250 gain, we're making it sensitive enough to be able to capture some faint detail. If I made that 0 gain, it wouldn't look like this at all. It would look very different from this. So it's pretty cool. Now, let's head back to this. So here's our supernova right here. And let's see if we can zoom in a little bit, Daryl, and check it out.
Okay.
Yeah, we're at 137% of our sensor right now. So that's, this will be a little brighter. We're going to tone that down. All right. And let's try to remove some of the noise.
The exposure time is the equivalent of shutter speed. Every exposure he's doing right now is 45 seconds long.
Yes, that's the amount that I pointed to earlier here, Preston. Hello, Judy M. Good to see you. Jeremy B says he loves the volcanic activity. I do too. I had a chance, although Oxford University Press didn't go for the book. I had a chance to be the data collection guy for going to some volcanoes in the South Pacific and climb volcanoes. I had that opportunity, but never got to do it because the author did not get green lighted. But we had a team. We were ready to go and just start doing lava collection and start analyzing results. I would have been the data collection guy if we did this, and I would have made sure that all the data was scientifically and properly gathered, and it's called chain of custody. Make sure that it was all labeled and tagged to make sure we know what we're looking at, and then do analysis and stuff. I wish we got to do that because that would have been a great trip, very memorable. But it would have been like 3 months in the South Pacific in the jungles of New Guinea. That would have been a little tough. Would have been a little tough.
It stopped sounding romantic as soon as you said New Guinea.
100% humidity, 90 degrees. Yeah, you just have to be willing to be, sweaty the whole time. Just got to be willing to.
They used to eat people over there.
Yeah, that's not so much anymore.
But that's New Guinea and Indonesia is certainly the place if you want to study volcanoes.
That's right, because the volcanoes are never quiet there. I still have some opportunities to go with some other folks to other volcanic places. And I'll tell you, it's a lot of fun, for instance, going to Sunset Volcano National Monument in northern Arizona, north of Flagstaff. And you walk through the lava fields there. You actually walk through the lava valleys that were excavated by lava, and it's just, they tower on all sides of you, and that stuff is sharp as glass. If you're not careful, if you fall, you're not going to get up without cuts, bruises, and lacerations. And the volcanic ash, for miles, it's just endless black hills. Occasional pine trees, a pine tree sticking up in the distance, and just incredible. It sort of looks like an alien landscape. I know they wanted to shoot some movies there, and they weren't allowed, of course, for good reason. But I think the Apollo astronauts trained out there. In fact, there's one spot where they trained with a lunar lander and so forth, just to try and figure out how to do lunar rock collection and stuff. That's one location they did. Okay. All right, well, we got 22 shots at 45 seconds here. So I'm going to save this here. We just got 23. See the color noise? That can all be removed. We can remove all that later. And we'll save it exactly as seen. All right. Now, if we zoom out, all right, we'll go to 33%. Gets us there. And what I have to do next is I have to come in and apply a flat field correction. Let's do that. All right. And now we saved it stretched like that. That looks good. So what we can do is clear this now. And because it's only 12:23, I'm thinking we can probably head out to look at some other objects.
Izabela wants to go see the koi fish galaxy.
All right.
I have to look it up first.
I think that's on the other side of the sky in the Virgo region. We'll do it. We do take requests, folks. If people know what they want to see, I'll show you. Hey, Fantasy, how you doing? Michael Hedrick, I don't know if I even said hi to you. I'm sorry if I hadn't. Okay. Let's get ready to rumble. Okay, so now what I'll do is we're going to go into our planetarium program.
It's in Coma Berenices.
Yeah, so it's that way.
NGC 4559.
All right, and I think it's actually in here as the Koi Fish Galaxy. Not that one. I think it's in there as this. Yeah, there it is. Okay. Yeah, sort of on the other side of the sky, but I think that is well within our range. Let's just check it out. Absolutely. It's almost directly overhead. So it's not too far from us, is it? All right, let's go there. That's a good choice, Izabela, because it's actually almost directly overhead. And that's the best view you can get, is when something's directly overhead. All right. There it is. So, let's move down. Bring our little koi fish up. Here we are. Then let's head west. Okay. Awesome. So we're stabilizing, we're guiding. As you can see, our telescope computer output saying we're guiding nicely. So off we go. Let's do a 35-second shot of the koi fish. It's a little off center, but that's not going to be a problem. And we'll do a live stack. Clear the last one. All right, now let's see. And as you know, because we're stacking, the first one isn't that good usually. The second one is a little better. There's the koi. How koi is that? And we have a satellite that zipped through while we're doing it. All right, so let's adjust levels. And then adjust color. And then we can zoom in. We have to wait for a few more images to come in first. But this allow us to see it. That's nice. Well, thank you, Izabela. I'm glad you like the new music. James Dugan, our friend from Australia, is in here with us, and he goes, haha, Elon, you done it again. Well, yeah, you know, on one hand, guess what? We used to use HughesNet out there. HughesNet gave us such slow speeds that it would make doing the stream unusable. Starlink at least makes it usable. And we're actually getting faster Starlink service in the coming weeks to months. And right now, we have what's called a low output site. You know, they don't have a lot of output that we can get from the Starlink satellites. We actually are kind of remote. So as the Starlink constellation, that's what they call all the satellites in orbit, a constellation. As the Starlink constellation gets filled out more, we'll be getting high output capability. And actually, the high output capability is a few miles west of us, and it's slowly moving to the east to where we are. That's pretty nice. Now, you know, people ask, why do you take pictures of the same thing all the time? Certainly there's plenty of objects to look at. There is. But here's what we're doing. We take a picture of this galaxy right here. Do you know if there's a supernova in it? No, you don't. How could you possibly tell? By comparing it to another picture of it, taken with the same telescope. And it doesn't have to be the same telescope, but it really is helpful having something with the same field of view. And so we have a database that we made out of our server. And the database allows you to search, for instance, on all times that we photographed, say that, okay, the koi fish galaxy. And so, that said, what we'll be able to do is go back and look at it and see how it looked back in, say, 2019, and look at it again in 2020, 21, 22, and compare all the images to see if anything's changed in the galaxy. We might find something else has changed. Maybe a star winked on in a nebula, and now there's a new nebula visible that wasn't before. So what we're doing is we're actually taking research data that you can use to actually do research, and we're making it freely available to all of you on our server. Where's our server? Go to skytourlive.org and scroll down just a little bit, and you can get to our server because there's a selection. It says take me to cool pictures, and you click on it, and it takes you to all the folders. You click into them, and you can get the images. Now they're the rough processed images like you see here, and you can click on them and see them. It's not like you have to it's not like you have to do anything to be able to see them. You just have to have a program that can look at them.
In fact, as for repeatedly visiting this object in particular, it contains a luminous blue variable, AT2016 BLU, experiences repeated supernova-like outbursts. Did it in 2014, 16, 17, 18, 19, 20, and 21.
Yeah, see, so that's why we do this. Right? Want to see it.
Sure.
Now, what we do is when we take the picture, when you download one of the pictures from our server, you might have a little noise like this in your picture. For the folks that are in our Patreon, we actually really hyper process these and literally make this just beautiful black space and show you the galaxy details. Look at this spiral arm right here, cranking out there. You see this beautiful spiral arm. It's sort of on an edge like this to us, or like that. And so it really looks really pretty, and you can see it has a yellowish core just like the other one, the Mesher 101, and it has blue arms, doesn't it? Same way as the other one, because that's the star forming regions in this galaxy as well, just as expected.
I think I see that luminous blue variable right now.
Where's it located?
10 o'clock in the nucleus of the galaxy. Very blue. There it is, right there.
Not that.
Oh, come on, you're no fun.
Oh, we have
Blue.
a luminous green variable. And a luminous red variable. These are actually just hot pixels that Daryl is funning you with. And they're not the same pixels every time. And we can clear we can clear those in post-production. Now the next telescope that we're getting right now, as we said, our field is 4 full moons across, 3 full moons tall. Clearly, this galaxy would benefit from being able to see it natively, at this size, and then enlarge it. All right, but unfortunately, because we're a wide field scope, we basically are zooming in on something that big in our field of view. So in order to make the best use, what we're doing is with the next scope, it's going to be a scope that has what we call more focal length. In other words, more initial magnification. So when you look at something like this, we're going to show you this image, the wide field view. And then right next to it, you're going to see the view of the object in the other telescope, same object, at its native size, which is going to be something like this. So that's going to be pretty cool. And that's what we're working on right now, is getting the second telescope. I designed the building and the way it's going to work. And at some point, I'll show you the design plan and how it all works. I have a little animation thing. It's going to be like a shell that opens like this. All right. It's not going to be a whole building like this one here. Okay. It's actually going to be an enclosure that covers just the telescope. And the telescope is going to be controlled by a small computer. And it's going to be inside this little enclosure, weatherproof. Okay. And it'll just open this way up and open up like flower petals, and then go down below the level of the telescope, right? So that we'll be able to see all the way to the horizon. Now that doesn't really help in professional astronomy. We actually worry about things called extinction and air mass, and we won't look at anything that's below 20 degrees above the horizon ever. In fact, 20 degrees, it might be more like 35 degrees or 40 degrees, depending on what kind of research you're doing. But we want to do that because we want to see some cool things, and we can see to the horizon. And in fact, if we can see to the horizon, we can see some really cool objects like Omega Centauri. That would be really cool. You know? That would be... Hello, Hunter. My son just got home from work. So there it is. And look at those beautiful blue spiral arms. These dots of blue stars. This is very, very hot regions in that galaxy. Very hot. Yes, it's like ominous. You know. And then you see outside here, you see this little area that's actually like a greenish area. Now, that could be a supernova remnant in this galaxy. They can grow that size, as seen from here. For example, Barnard's Loop in the constellation of Orion is an old supernova remnant. It is larger than the entire constellation of Orion overall. And so it would be under exposure from a great distance away. It would be visible as something that would be really very impressive as seen from another galaxy. But it is kind of faint, but you'd still see it on a long exposure. Very nice. Okay, so this is the Koi Fish Galaxy. I'm going to just put the word gal at the end to show it's a galaxy.
You know, while we're in coma,
yeah,
got to do 4565.
Oh, who wouldn't? That's a great galaxy.
And you got M64 and
M64 is probably within reach right now. You know,
M53 is a nice globular. M85, M100, M98, M99, M88, M91.
Yeah. Okay.
We'll keep this open for a while.
Sure.
In case you want to go back to it for reference.
All right. So let's. I've saved this out there as the Koi Fish Galaxy, and that was a request from Izabela and Melamed in Sofia, Bulgaria. And it's all yours to play with, Izabela, and it's all ours to play with as well. So let's go back now and brighten up our scene. Okay, and I'm going to drop the gain a little bit down to 200 and repurpose that. Okay, now get our computer back up and running here.
We are. There you go.
Okay.
I noticed earlier your progress bar down at bottom right was being very pokey at times.
Yeah, that's unfortunately what happens with this, Again, Starlink is not the fastest that we want it to be at times. But I wish it was a little faster, but it sometimes isn't. All right, let's do one thing here.
When you see Coma Berenices there, folks, that means Berenice's hair, or Berenike's hair, actually. Berenike was a queen. I think she was a queen of Egypt. And her husband went off to war, if I remember correctly, and she had beautiful hair. She offered her hair as a votive offering that it might help her husband come back safe from war. And I guess that impressed the gods so much they put her hair up in the sky.
But he didn't come back, did he?
No, he came back.
Okay.
I believe so.
All right. I'm just doing an adjustment here. Bringing that. Okay, the progress bar wasn't quite in the view properly. Okay. All right, so where do you want to go now?
4565.
Alrighty. Let's do that. Let's first of all, I'm noticing that we're having our typical internet slowdown that we sometimes get. But NGC 4565. Really quite a nice location. This is a beautiful galaxy. And is it literally right next to the koi fish?
4565?
Yeah.
I don't know.
Well, the telescope is barely moving, so I think it is.
The chart I'm presently looking at doesn't show
Okay.
the koi fish.
Alrighty, I'm gonna go to 50% here. There's the Needle Galaxy right there. These diagonal artifacts are actually not really there. They are actually on our helper image that we're using called the flat frame reduction image. So this is what it looks like without it. And I have to take more efficient flat frames in order to get this to look better. So we'll do that. Not tonight, though. Look at that, Elon. That was a Starlink satellite. All right, let's go south to pull this in. That's a little too far south. There we go. And now we'll go a little bit to the west. No cosmic ray. We actually have we have a database, a set of database tables that we're working on. He's asking if STLS is really a database or just a collection of file folders. Now we're working on a database right now with proper tables. I designed databases for several years, and feel that the databases that are important are the ones that have properly made tables, and that's one of the things that we had to focus on. So I'm working on that. I just changed my flat frame to a different file. So we'll try that. See what it does. Okay, now what we'll do is we'll take a picture of this guy. This is 4565, the Needle Galaxy. I hate needles. Don't you?
I'm sorry, say again?
It's alright. Okay. I said I hate needles, don't you?
They don't bother me.
Oh, good. Alright.
I'm sorry, you're cutting out on me again a little bit.
Yeah, that's your Skype. It's I don't think it's in the stream. Okay, there's our needle right there. Let's process it. Give it some proper levels. Look at that. Isn't that something?
Nice.
That was a good suggestion, Daryl. It never fails to impress.
Oh, yeah.
Yep. Wow. Okay, we'll let this one collect a few photons. Okay. All right, and this one here, just to get it out there, is NGC 4565, known as the Needle Galaxy. Hello there, Marcin Johansson. Good to see you. Yeah, Preston, relational databases are phenomenal, and made right, these are really impressive to use, easy to use, efficient, you know. Okay, let me... Let's go back here.
Dean, to the lower right.
What was the question?
Another galaxy below 4565.
Yeah. It's hard to remember, but when people ask questions, not everybody's reading it, so I try to remember to read the question too. You know what, Dean Bostador, I didn't say hi to you before. I'm sorry. Good to see you. Donald Kunzer wants a hamburger. That's available.
Yeah.
We can check out the hamburger, Donald.
Yeah, it's really not far from here.
No, not realistically.
No, Colma sits above Leo's hindquarters.
Mm-hmm. Look at that. That's really pretty. Let's see if we can color correct that dust. The telescope is performing admirably. There's no wind out there right now. So this is a galaxy that is almost nearly edge on. It's slightly tipped just a little bit. So you see this is the edge at the midway point right here. This is the dark dust which focuses in a disk around the nuclear bulge of the galaxy. And we're seeing we're seeing a little bit more of the bulge here, a little less here. So the galaxy is slightly, not this way, but tipped tip to us just a little bit. I know this galaxy actually was one of the first ones that one of the first ones you told me about, actually, that you really liked because of the nice lane there and dark lane here that goes down the center.
Oh, it's a classic.
Yeah.
Fantasy asked about seeing the Iris Nebula. It's in Cepheus. Cepheus is pretty low yet.
It is, yeah. Yeah, because the Elephant's Trunk Nebula is down well below the North Star, and it's sort of near the Elephant's Trunk Nebula in that regard. Remember how grainy this was? You notice how it's looking a little better right now?
Yeah.
We'll turn that name off right now. We don't need it. So we're adding, we're at 10 frames now. Very nice. Hey there, Marco. How are you? Okay. Ah. Well, see, I'm doing a successive stack, you know. I'm not saving individual files. If I did, then I could just not stack this. And that's capable. That's possible here. It's a capability of the software. But I do know that this was a one-time event. Sorry. So what that means is, over time, this is going to fade out.
I would guess that has to be 2 satellites passing.
I think that's correct. And sometimes
nearly identical orbits.
Yeah, well, they could be, they could be sister satellites that are part of a Navy ranging satellite tandem orbit project or something.
I saw Iridium satellites do that a few times.
Yeah. But that is actually a good one to show the problem we have, so I'm going to save it before it starts to work itself away. Now, Michael, that's not an airliner because we don't have the lights that over this size of the field. We would see other lighting on the aircraft. All right, and at this point where the telescope's pointing, if that was an airliner going over, it would move slower than we see here. Because it would be at a very, very high altitude if these were the wingtips.
Yeah, I was out watching for an Iridium flare one night.
Yeah.
And with practice, I got to where I could see them well before and after the flares.
Mm-hmm.
And here came the one, but then there was another one just very slightly behind and next to it. And the first one flared, and then the second one flared a second later. Very close together in the sky. It was really cool to see.
I had a Mars party out in the front lawn here, and the observatory was open. People were seeing, stuff in the telescope. And then I ended up, we had lawn chairs. Everybody was out here. We actually had ham radio operators out in the front, all their equipment set up and listening in for satellites and the space station and stuff. And as the last car left the driveway when everybody left for the evening, I looked up and said, what a beautiful night. Just at that point, 2 bright headlights appeared over my head. 2 bright headlights. And what they were 2 iridium satellites flaring at the same time. And they were exceptionally bright, like first magnitude or at least. And I looked down on the ground, and it was such a directed glare from these satellites, I could see my shadow as these things moved across the sky. And they were there. They occurred for like 1.5 to 2.5 seconds. But I saw my freaking shadow by satellite reflections onto the ground. Again, it was very dark here. Amazing. Yeah, but as Daryl points out, the Iridium constellation is being slowly deorbited. I don't know if they're all gone yet.
They put up a new constellation of them, didn't they? A new model that don't flare like the old ones did?
Yeah, correct. Yeah, the old ones are just getting deorbited. And they go, you know where they go? They go to the satellite graveyard. Where is that? Well, there's 2 of them, actually. One's in the southern Indian Ocean, where actually MH370 is probably located. And then they went to a place in the Pacific that no one goes to. And they can actually deorbit them into those locations.
Yeah. Marston Johansson had a question a minute or 2 ago.
Yeah, I was about to answer it, and then you
Niño?
mentioned, I don't know, Marston, what El Nino would do. I think it's very possible that it could affect our view, but keep in mind that the monsoon season out in Arizona is about to begin, and it usually runs somewhere from June through July to August. And what that means is, no, it doesn't mean it's rainy every day. It just means we do have clouds more often than not in Arizona. But last year, we were able to see some amazing sights anyway. We got a beautiful view of the summer sky. And I'm sure we'll continue to get one this year.
I watched the weather guy on YouTube, Ryan Hall, y'all. He gave a big rundown on El Nino a week or so ago. Basically, sounded like potluck to me. I mean, it could be like this or it could be like that, depending on where you are and where the wind blows.
Yeah. That's a beautiful galaxy.
It is. Marson, all the mountains in the most of the mountains in the western United States had a really big snow year this last winter, and California really got it. Most of Colorado got it, and they're keeping their fingers crossed for a really good runoff this year. But still, it's just it's a short-term solution. The Colorado River is so heavily oversubscribed, it's ridiculous. All the way from its headwaters here in Colorado, all the way down to the Gulf of Baja.
Wow.
It barely reaches the Gulf of Waha anymore.
Yeah. Terry Haig says, you would have loved how dark our street was when I was a kid. 2 street lamps on the whole road.
Yeah.
Yeah.
They
Well,
were
we've all had those.
much dimmer lights back then, too.
Yeah. Yeah. Okay, we're at 28 here. I'm going to stop this here. We've got that set up. Okay, save exactly the scene. Alright, so now we can clear that. And go back to our night vision mode.
You want another
I was
one?
wondering... Huh?
Do you want another target?
Yeah, we'll do one more.
Well, you can, I'd rather fight than switch, or got a bunch of M objects in coma. Some good NGC objects too.
Yeah.
How about M100?
Alright, we'll do M100. Before we do M100, I'm going to do one quick thing. I noticed that we're getting some wind out there. I just saw that. I'm seeing a haze over some of the objects we're taking pictures of. And I want to make sure that it's not the moonlight or any high altitude cirrus clouds, which can sometimes come in. Okay, why'd that go away? I did not want it to go away. I see we got some wind out there. Alright. Okay, I'm trying to... That's what I want. See, it's 10 o'clock out there. And see, that seems to be a time when people get on the internet, and Starlink has bandwidth issues like every other internet provider. I'm literally waiting for this to come up. That's takes a long time.
Looks clear as a bell on windy.
Yeah, it does. All right, let's
Cloudy here, I think. Yep.
all right, let's go see what this is going to show us. Hey, Sandy boy. Yeah, see, the moonlight is interfering with us. Not that bird turd on our image there.
Boy, Leo's getting pretty far over in the west now.
Yeah. The sooner the better. I want summer sky. Okay. All right. So what object do you want to go to again?
Try Messier 100.
That's what you said. That's right. Okay, let's try M100. No, let's go to the Veil. Let's do the Veil Nebula. I'm kidding.
Oh, it's probably up.
It's up. It's just low. Okay. Oh, didn't want to quite do that yet. We're going to say, go there. It's right near this, of course. So let's go check it out. And let's go back to like 40%. There it is. So let's drop in on it and say hello. The flat field correction that I'm applying is meant to balance out the field, because when you take pictures, the center is going to be brighter than the exterior areas. And what this will do is the flat field kind of reverses that. But when the moon is out, it changes the brightness of the sky and makes it harder for this to work right. So we're going to try and run without that. All right, and we're guiding now, and we should be okay. Let's see if we can do a 35-second shot. And we're at 200. I'm going to drop us to 150. Okay. 150 it is. And so a 35-second shot at 150. And we'll stack it, but not before we remove the previous stack. It's been saved, and it's up on the server as we speak. Okay. Let's process these a little bit. There we go.
I see galaxies.
I do too. We got M100 here. We have... is this also called the Grand Design Spiral?
I believe it is.
Okay. We got one here. Well, let me just... while we're at this location... we have a galaxy here. We have a galaxy here. There's a galaxy here. And undoubtedly more. Actually, there's a really faint one right there. There's a faint one right here. And many more, undoubtedly. In fact, if I zoom out fully, I wonder if we can see even more.
M98 and M99 are just to the lower right of M100. M91 and M88 are just to the lower left.
Oh,
Far away.
yeah. Oh, that's one. That's right. There's one right here. There's one right here. And it looks like there's one right here. Actually.
One up in the upper left corner.
Up here?
Right there.
Oh, right there. Duh, yeah.
There.
Yeah. Sure.
There's a dimmer one down toward the lower left. A little bit.
Actually, this is one too.
That's there. And there's a couple to the upper left of there.
Oh, that's right. There's one here. Maybe that's two.
Looks like two.
Yeah. So as you can see, folks, this is really an exciting area of the sky. Very exciting. Of course, then we have our Grand Design Spiral right here. All right, so that said, can you see them again now? All right, we'll zoom in on this. And of course, we can see galaxies even better once we have this zoom factor.
I would call that a grand design spiral.
Yep. I would. Very nice. Again, removing the flat frame when the moon is out is kind of where you have to go with this sometimes. Alright, so let's darken up our background a little.
Oh, it's 4 days old. It's not that bright.
Well, it's affecting the images, the flat frame.
Michael Hedrick has a pretty loaded question for you.
Renee Cruz wanted to ask a question about Big Bang and our visual horizon of the universe. Could we chat about it a bit, please? Our visual horizon, well, that's interesting because, as you know, we have seen out 13.6 or so billion light years. The universe is 13.8 billion years old, but the universe was opaque at the very beginning, and only after atoms could form and bunch up particles in neat little packages called atoms was the universe more transparent. And when that happened, then we noticed that we could see out to that remnant of the Big Bang. So, what?
I'm sorry. I'm looking for Renee's original question. It was in relation to the recent results from the Webb telescope.
Okay.
You know, there's been a lot out there recently about how, you know, Webb is revolutionizing cosmology and all that, and I have to take it all with a grain of salt. People are blowing all sorts of smoke on YouTube and elsewhere that, we saw the other universes. And
Well, until science says it, it's only conjecture. Until it's been proven through a rigid, what's the word? Rigid proof. All right. In other words, it's got to be very regimented. You can't take shortcuts. You prove it, or it doesn't really exist. You got to prove it. The evidence is there. Make use of the evidence.
her question, I could copy and paste it back in chat again. It's up quite a ways. What is beyond the image captured by James Webb Space Telescope of the Big Bang Theory, space and time, spiritual dimension, parallels, matrix grid, the 11 dimensions, God? Question mark.
That is a loaded question.
That's why I called it that.
Yeah. Well, first of all, what's out farther than the Webb can see is actually more galaxies, most likely. Because here's the weird thing, okay? The Webb is looking back to literally just about 300,000 years after the universe came into existence. And so that means that, and we're seeing fully formed galaxies at that point, and that really blows our minds, especially in the cosmology arena, because it's really not, it's really something that doesn't match what we understand of the universe. You shouldn't see fully formed galaxies at that point. You should see galaxies in formation, not fully formed galaxies. But we see fully formed galaxies. So that's pretty interesting that we see that. So that's something that we're trying to, figure out. But it's something that's really, really hard to decipher right now. Now, what's out beyond the edge? Well, first of all, where is the edge? You gotta keep that in mind. Where is the edge? We see out the Webb sees out 13.6 or so billion light years into the universe, and we can see the cosmic microwave background. So is that how big the universe is? Is it like 26 and change billion light years in diameter? 13.6 times 2? No. And the reason is because we're seeing that light after it's traveled 13.6 billion light years to get to us. So in that time, the universe has also been expanding out far beyond where we will never see. And when you count the fact that the universe is accelerating as it expands, as it turns out, now that puts the actual diameter of the universe at 92 billion light years. 92 billion light years. Not 13.8. So there's a whole lot more to fathom here, right? And I think at some point, Daryl, we need to do a show on this for SkyTour Radio. I think it'd be very important to do a show on this to really point out to people how the universe works and how that size of the universe has been arrived at mathematically, but do it in a way that everybody can understand. And I think that's a good idea.
Yeah, well, parts of this question are beyond the realm of science, frankly.
Sure.
Spiritual dimension, God.
Yeah, I couldn't address those, but I could address the physical stuff.
Yeah.
Yeah. Let's zoom in here on our beautiful Messier 100.
You notice, I pointed this out with other galaxies before. This is called a grand design spiral. And if you drew a line from any direction straight through the center of the galaxy, you would imagine either side of that line would be pretty much the same. But you can see actually it's not. That innermost spiral arm at about 9 o'clock, it's got that great big lump there on the left side of it. And the arm on the farther out on the left side, curling up over the top, it looks distorted, different than the similar arm on the right side.
Yeah.
As ever, it's signs of gravitational interaction, and those two fuzzies farther out at 9 o'clock and about 11:30 are good possible candidates, sort of like when we see the Whirlpool galaxy, the secondary galaxy there, is distorted the one spiral arm really badly.
Right. So he's talking about,
seeing a similar thing happen here.
Yeah, actually, Daryl's referencing this galaxy and this galaxy here, but we also have to consider this one and this one. Where have they been over the last 100 million years, 2 billion years? What about that one? Maybe all of these interacted with this galaxy. We don't even know it yet. Oops, sorry about that. That was a mistake.
And keep in mind, too, though, that we're seeing a two-dimensional look at a three-dimensional area of space. And, how are those galaxies situated relative to Messier 100?
They could be much further away or actually closer.
Yeah.
And very small dwarf galaxies. But we have an idea what these are. So it's possible that Messier 100 did interact at some point.
Yeah. It's a pretty galaxy, though.
Yes, it is. It's very pretty.
And whoever it was, Marson or someone had asked her, or Fantasy, I forget, had asked about seeing the Hamburger Galaxy.
Yeah, that was
Uh,
Donald Kunzer asking for the hamburger.
Donald, Leo's starting to drop. You might still be able to catch it
Yeah,
if you
it's
want to.
actually it's 1:30 here, so I'm actually gonna have to hit the hay.
Oh,
So uh, I think for now we did our task. We actually checked out Messier 101 and the supernova and a few other objects that we hadn't seen the other night. And Ray, don't worry, the veil's coming up. We're gonna be getting a veil for you, and we'll take pictures of it endlessly. And we'll make sure they're also fuzzy and not quite in focus. Because I guess that's, we'll do it during the full moon.
but that image looks very three-dimensional. Could we take a last peek at Supernova before you go tonight?
Yeah. Let me save this. Okay. So it's all out there. So what we'll do now is go back to our 1 second night vision mode. Okay. See, this is an overall brightness that is brighter than normal, and that's again because of the moon. It's adding enough sky brightness. There might also be water vapor, oddly, in the air out there. Terry Haig, Daryl is not on Facebook. We're trying to work the problem, though. We'll try and get him on Facebook. Okay. Alright, we're going to go look for this again. Off we go to the Pinwheel Galaxy for one more look.
Yeah. Yeah, Leo, Coma Berenices, Virgo, they're all west of the meridian now. They're in decline. Galaxy season is going away.
I'm okay with that.
But here comes the stars of summer up in the east.
Yeah, we're going to do that thing I mentioned the other night where we're going to start down low in the Milky Way and just move up and just look for objects that we can find. Nothing specific. It's really fun to just amble along in the Milky Way and see all the details in it.
I agree.
Okay, why can't I see the galaxy right now? Oh, I know why. I'd have to turn up the gain. Yeah, when I turn up the gain. There it is. Alright. Okay, so we're going to go south. And then go west. Think of it as the telescope moving in the sky. It's moving toward the west. It's moving toward the east, toward the north and south. Okay, so now let's come back here. Do that. All right.
One last look to remember it by tonight and for the late arrivals.
Yeah. Hey there, Rocket City Astro. How you doing? He's doing M24 right now.
Uh-huh.
Hey, you've arrived when you're doing a stream in astronomy and other folks doing astronomy are watching your stream while they're doing their astronomy. I think that's pretty cool. Okay, we're guiding well right now. Let's do a series of 20-second shots. I think that's good for this one.
M24 is where that new object is that that Bray Falls guy
Yeah.
discovered. Izabela posted to us recently.
I recall. That's a interesting object.
Another big O3 area.
Mm-hmm.
Rocket City does a live stream.
Very cool. You did M24 tonight? Thank you for saying that, Terry. That was very nice. Okay, Cosmic Ray. See you later. Bye. I don't know what it is with you, Ray. You have nothing but complaints about my family here. You're about to lose your wrench. Okay, Rocket City says he uses Nina and a Sharp Cap together. Yeah. I use astrophotography tool, Sharp Cap, and then my security cameras.
I followed that link that Ray posted. Did you see it?
No. I can't click on a link in there because it'll mess up my chat.
Yeah. It's about a manure spreader, so I guess we should feel insulted.
That's what he's trying to do. Hello, Anthony DeSanto. How are you? Yeah, let me properly give us some processing here to show this. Looks quite nice. So if you notice, right, we come in here. Let me do the color curves just a little bit again. There we go. So if you notice, if we zoom in a little, you see, here's our spiral arms. Again, we only have 8 stacked right now, so this is more what it should look like. There's our supernova, that little blue dot right there. Okay, the supernova is this exploding star. It's hot, so it looks blue. Hot things in the universe
look
look
blue again tonight.
It does, and I think it's this is only a 20-second exposure, so I didn't saturate it as much.
Okay.
And if I do this, if I actually, oh sorry, I can't do that. If I come over here and I reduce our mid-range here, you can see the blue shows up even brighter here.
Yeah.
Yeah.
Cool.
Yeah. Excellent. Okay. So are you guys having a good time? Are you enjoying checking out the galaxies as we do? I hope you do. 'Cause I'm having a good time.
Okay, well, thank you for the encore review, Mark. Don't let me keep you up late.
No, it's okay. I just just wanted to make sure that we did get this last view, and I'm going to actually save it as well. I mean, while we're here, right, if we're doing it, I'm not going to just skimp on it.
Oh.
We're going to do it.
Appreciate it.
Yeah. All I can say is, in that galaxy right now, right at that spot, there's nothing that could live in that outward flowing maelstrom of cataclysmic explosive power. Oh, sure thing, Anthony. So when I mean, I'll be streaming probably before I head out to Indian Wells, California, which is near Palm Springs, to do this conference. We'll be doing, like I said, a live SkyTour live stream. We'll be doing a talk on some advanced physics, but it'll be at lay level, so anyone from off the street will be able to understand it. And I'll also be working with Ben Hansen on his Skywatch, and then Ben's going to work with me on my live stream. So it's going to be a wonderful weekend. And, of course, we'll sell books and other things. If you're interested in a book, there's a good book on life in the universe that was written by this crazy astronomer who runs a live stream. Sounds like me. And it's called The Populated Universe. If you're interested in seeing why carbon is so essential and so forth, that's a book for you. It's all layman's level. So, and the other thing about it is, you know we're not alone in the universe. You know that, you sense it. Everybody knows it's true. We have UFO reports from all over the world of all different kinds, encounters and so forth. Something's happening. Something's going on out there. So the question becomes, when people say, I can't believe we're alone, and then they leave it at that. Because if someone says why, then they just say, well, I just can't believe we're alone. It's a vast universe. Look at the universe. Well, that's not good enough, in general. So what makes it a way to get a better answer, it comes from the book, because the populated universe tells you why carbon is probably the predominant life-giving element in the entire universe. We see it everywhere. You see those dark lanes in the galaxy that we're seeing here? All those dark lanes of dust are made of carbon atoms and silicon atoms and other debris that were created in the death of a star. So the death of a star leads to the birth of planets. And so it all has a lot to do with carbon. Carbon is extremely capable. And if you look in the vertical column in the periodic table, you have carbon, and then right below it is silicon. And people say, well, what about silicon-based life? It's the next most likely atom and most likely capable atom that could create life, right? But guess what? Silicon is really tenacious. When it makes a bond, it doesn't like to give it up. And when it makes a bond, it tends to make crystalline structures. So when we look at carbon, on the other hand, carbon makes and breaks bonds with ease, and it bonds with more things in more ways, with more variations and more flexibility than any other atom in the periodic table, and we call it the granddaddy of elements. So it's most likely life engendering. So I think, in my view, it's a template that the universe provides because it makes so much carbon, fourth most abundant, remember, and so much oxygen, third most abundant, next to helium and then hydrogen the most, that it's probably a carbon-based universe for life, in my view. So that all said, I think it stands to reason that the carbon-based life in the universe is probably the way of all things. And so when we see a supernova like this, it's the death of a star, but it's going to yield the potential future of planets with life. Every element that's in your body was manufactured in the heart of a star, either through fusion reactions or through supernovas. How about that? Every single element in your body. So I think that's kind of where we'll leave this. All right. So it was great to have you guys on board with us tonight. And we'll come back another clear night and check out more things. Keep in mind, galaxy season's coming to an end, and the summer sky with the very Milky Way that we live in is going to be rising up. You'll see the center of the Milky Way with our SkyTour live stream telescopes sooner than later. You think this is a lot of stars? Just wait. Stars from edge to edge, denser. They're so dense they look like a wet driveway. It's just incredible. No, it's not a wet driveway. All right. Well, you guys, I hope you have a really good night. Thank you so much for coming out here. And thank you for tolerating my little journeys of exploration that I take with you. I really appreciate your attendance. I really appreciate you. And if you want to come to skytourlive.org, join our Patreon, be one of the family. You get things for that. And please enjoy. If you want to make a one-time donation, you can also do that for us as well. We would really appreciate that. We want to keep bringing this to you. So you guys have a good evening, and we will talk soon.
Good night, everybody.
And Daryl's out of here, and so am I. You guys have a good evening. We'll talk again. Good night.